Hello and welcome to SDKBench. In this video, we'll be building our Audit Log API using ASP.NET Core, Entity Framework Core, and SQL Server. Let's get started. The first thing that we're going to do is create our new project. In this case, we'll be creating a web API using the .NET CLI. So let's run the .NET new web API command. We're going to call it auditlogs.api, and we're going to be using the use program main flag and the controllers flag. Alright, so the .NET CLI generated our project, and now we're going to open the project with our preferred IDE. In my case, this is going to be Writer. Now let's open this project. Also, I'm going to open up a new tab on the terminal. And before we continue, we're going to generate a global.json file. What this global.json file will do is it will map a particular SDK version to our project. So let's generate this global.json file using the .NET CLI. .NET new global.json, and we're going to specify the SDK version 8.0.417. Press enter, and our template was generated. Next, we're going to install the .NET EF tool. This will allow us to make updates to our database via the entity framework. But rather than installing this tool globally, we're going to pin it to our project. This can be achieved using a tool manifest. We can generate a tool manifest once again by using the .NET CLI. So let's run .NET new tool manifest. Tool manifest file has been generated. And let's install our tool, the .NET EF tool. And we're going to specify the version 8.*. Alright, the tool runs successfully. If we try to run the tool outside of this project, you're going to see that the tool is not recognized because the tool is only installed within the scope of that project. Now let's CD back into our project, and we're going to continue by installing some packages. The first package that we're going to install is the Microsoft Entity Framework Core SQL Server package. This is the database provider for Entity Framework Core. It will allow our application to communicate with the SQL Server. We're going to specify version 8.*. Now let's verify that the package was installed successfully by checking our CS_proj file. Okay, and as you can see here, the package was installed successfully. The next package that we're going to install is the Microsoft Entity Framework Core tools. This package will allow us to execute commands like add migration, update database, and remove migration. Again, we're going to specify the version as 8.*. Let's clear our screen and let's run the application and make sure everything works correctly. Okay, everything works. Now we're going to get started with removing all the boilerplate code that was generated with the .NET CLI. Now let's make sure everything still runs. Let's clear the terminal and execute .NET run. Okay, everything looks good. Now let's first begin by defining the different models in our API. Let's create a new folder called models, and let's define a new class called Audit Log Entry. Next, we're going to add a few properties to this class. This new class that we're creating, the Audit Log Entry class, will represent a table in our database. Object relational mappers use classes to model database objects. Now that we have created our model, the next step is to create the app DbContext. The DbContext is what connects our application to the database using Entity Framework. It is the bridge between our .NET application and SQL Server. Entity Framework uses the DbContext to understand which classes should become database tables and how we should track changes to those objects. So now that I've created my app DbContext class, I'm going to begin by bringing in some Entity Framework namespaces. Now that we've added our Entity Framework namespaces, we're going to inherit from the DbContext class. Now I will begin by adding the constructor. This constructor accepts DbContext options. These options are where Entity Framework will receive configuration details such as the database provider and the connection string. We are not hard-coding the connection string directly inside this class. Instead, we will configure that later in program.cs. This keeps our setup cleaner and easier to maintain. Next, I'm adding the dbSet. A dbSet represents a table that Entity Framework can query and save data to. So this line is telling Entity Framework that we want to work with a table of audit log entry records. Later, this will allow us to do things like add new audit log records, query audit history, filter logs by action, entity, or date. Next, we'll be overriding the onModelCreating method. This method lets us configure how our model should be created in the database. For example, instead of putting all the rules directly on the model, we can define some database rules here using Entity Framework's Fluent API. Here, I'm configuring the AuditLog entry entity. Inside this block, I can define rules for specific columns. For the action property, I'm making it a required field with the max length of 100 characters. Then, I'm doing the same thing for the entity property. Next, I'm configuring the performed by property. This tells us who performed the action. In a real application, this could be a username, email address, user ID, or even the name of a system process. Finally, I'm adding an index on the UTC timestamp. This is useful because audit logs are commonly searched by date. For example, an admin might want to see what happened today, this week, or during a specific incident window. Adding an index helps the database find those records more efficiently as the table grows. Now that we have our app DbContext created, the next step is to connect this API to an actual database. For this project, I'm going to use SQL Server running inside Docker. The reason I like using Docker for this is because I do not have to install SQL Server directly on my machine. I can run SQL Server inside a container, connect to it locally, and if I ever need to reset the environment, I can stop, remove, or recreate the container. The container is going to expose SQL Server on port 1433, which is the default SQL Server port. Now that SQL Server is running locally, the next step is to add a connection string to the API. So I'm going to open appsettings.json and add a connection string section. This connection string tells our application where the database is and how to connect to it. Server equals localhost 1433 means the SQL Server container is running locally and listening on port 1433. Database equals AuditLog DB is the same name of the database we want Entity Framework to use. User ID equals SA and password are the SQL Server login credentials for this local development database. And trust server certificate equals true is useful for local development because we are not setting up a full trusted certificate chain for this demo environment. One important note for a tutorial, it is fine to show a local development password, but in a real application, you would not hardcode production secrets directly in appsettings.json. You would use user secrets, environment variables, Azure Key Vault, or another secure configuration provider. Now that the connection string exists, we need to tell ASP.NET Core and Entity Framework to use it. So I'm going to open up program.cs. This is where we register services for the application. Here, I'm adding the app DbContext to the dependency injection container. Let's break this down. App DbContext registers our database context with the application. That means later, when a controller or service needs to access the database, ASP.NET Core can automatically inject an instance of app DbContext. The Use SQL Server part tells Entity Framework Core that the database provider is SQL Server, and builder.configuration.get connection string default connection reads the connection string that we just added inside app settings.json. Before moving on, I'm going to build the project to make sure everything is wired up correctly. In the terminal, I'm going to run .NET build. If the build succeeds, that tells us our code compiles, our Entity Framework packages are being recognized, and our app DbContext registration is valid. At this point, the API is ready for the next step, which is creating our first Entity Framework migration. The migration will take our Audit Log entry model and turn it into an actual SQL Server table. A migration is Entity Framework's way of describing a database schema change. Entity Framework examines our current model and compares it against the existing migration history. Because this is our first migration, it will generate everything required to create the initial database structure. I'm naming this migration Initial Migration, but migration names should generally describe the change being made. Once the command completes, Entity Framework creates a new migrations folder. Inside that folder, we have the generated migration file and a model snapshot. The migration contains two primary methods, up and down. The up method describes what Entity Framework should do when this migration is applied. In this case, it creates the Audit Logs entry table. We can see the columns generated from our Audit Log entry model. Entity Framework also applied the maximum lengths and required field rules that we configured inside app DbContext. At the bottom, it creates the index for occurred in UTC. That index will help SQL Server search and sort audit records by date more efficiently. Creating the migration only generates the instructions. It has not applied those changes to SQL Server yet. To create the database and apply the migration, I'll run .NET EF database update. Entity Framework connects to SQL Server using our configured connection string, creates the database if it does not already exist, and applies every migration that has not yet been applied. It also creates an internal table called EF Migration History. Entity Framework uses that table to track which migrations have already been applied to the database. Now, I'm going to connect Writer's Database Explorer to the same SQL Server instance. I'll use the connection string from appsettings.json, test the connection, and connect to the database. To verify that the table was created, I'll run a simple SQL query. The query returns 0 rows, which is expected because we haven't created any audit records yet. The important result is that the table exists and contains the columns defined by our model and migration. Our Entity Framework configuration is now connected to SQL Server, and the initial database schema has been successfully created. Next, we can start building the API endpoints that will write audit log records into the table and retrieve them from our database. Before creating the controller, I'm going to create a request DTO. Inside the project, I'm creating a new folder called DTOs. Then inside that folder, I'm creating a record called Create Audit Log Request. The request includes the action that occurred, the entity affected by the action, an optional entity ID, the user who performed the action, and optional metadata. Notice that the request does not include an ID or timestamp. Those values should not be controlled by the client. The database will generate the ID, and the API will generate the UTC timestamp when it receives the request. Using a separate DTO also keeps our external API contract separate from our Entity Framework database model. Next, I'm going to create the controller that will receive the request. Inside the controllers folder, I'm creating an API controller called Audit Logs Controller. Our controller needs access to the database, So I'm going to inject the app DbContext. ASP.NET Core's dependency injection system will create the context and pass it into this constructor. We registered app DbContext earlier in program.cs, so it is now available to controllers and other services throughout the application. Now I'm creating the post endpoint. The HTTP post attribute tells ASP.NET Core that this method handles HTTP post requests. The request body will be converted from JSON into a created AuditLog request object. Inside the body, I will be adding a simple try-catch block. This handles any exceptions that occur within the endpoint and returns a 500 internal server error with a generic message in the response. Inside the method, I'm creating a new AuditLog entry. This maps the incoming DTO to our entity framework entity. Most of the values come directly from the request, but the timestamp is generated by the API using datetime UTC now. Next, I'm adding the entity to the database context. At this point, entity framework begins tracking the new entity, but it has not sent anything to the SQL Server yet. To persist the record, I call _DbContext.SaveChanges async. Entity framework translates the track change into a SQL insert statement and sends it to the database. Once SQL Server saves the record, Entity Framework updates the entity with its generated ID. For now, I'm returning a successful response so that we can verify the endpoint. Next, we'll use Postman to create a post request using the controller route. When I send the request, ASP.NET Core binds the JSON to our create AuditLog request. The controller creates an AuditLog entry. Entity Framework generates the SQL insert, and SQL Server stores the record. We receive a successful response, which confirms that the endpoint completed. We can also see Entity Framework's generated insert statement in the application logs. Now, I'm going to verify the result directly in SQL Server. The new record appears in the table with its database generated ID and the values we submitted through Postman. During the first test, I noticed that the timestamp contained the minimum .NET date instead of the actual time. That happened because occurred and UTC had not been assigned before the entity was saved. To correct that, I added occurred in UTC equals datetime UTC now. Now I'll send another request with different values. After sending the request, I'll refresh the SQL query. We can now see both audit records and the new records contain the correct UTC timestamp. At this point, our API can receive an audit log request, map it to an entity framework entity, save it in SQL Server, and return a successful response. Now that the API can create audit log entries, the next step is to retrieve them from the database. I am adding an HTTP GET endpoint. The method accepts 4 optional filters: user, action, from UTC, and to UTC. Because these parameters are nullable, a client can request every log or narrow the results to a specific user, action, or date range. The method returns a read-only list of audit log entry objects. I will begin with the audit log entries DB set and call as no tracking. This is a read-only operation, so Entity Framework does not need to track these records for future updates. I am also calling asQueryable. This lets us build the database query one condition at a time before it is executed. I check whether the user parameter has a value. When it is done, I add a where clause that compares performed by to the supplied user. I repeat the same pattern for action. If an action is provided, only records with that action are included. The date filters use nullable datetime values. From UTC includes records that occurred at or after the supplied time. To UTC includes records that occurred at or before the supplied time. At this point, Entity Framework has not queried the database. We're only building an iQueryable expression. The conditions are combined into one SQL statement when toListAsync is called. Before executing the query, I order the results by occurred in UTC in descending order. This places the newest audit events at the beginning of the response. Finally, toListAsync executes the query and returns the matching records. In this final section, I'm cleaning up the search endpoint by moving its filters, into a dedicated request object. The original method accepts 4 separate parameters. That works, but as the endpoint grows, a long parameter list becomes harder to read and maintain. Inside the details folder, I'm creating a record named Search Query Request. It contains optional user and action strings along with nullable datetime values named from UTC and to UTC. Making each property nullable means the client can provide any combination of filters or omit them completely to retrieve all records. Back in the controller, I replaced the 4 individual parameters with one search query request object. I then update each condition to read its value from the request. The query still begins with as no tracking because this is a read-only operation, and each where clause is only added when its corresponding filter contains a value. After correcting the timestamps, the request succeeds and the endpoint returns only the audit records inside the requested date range. And that completes this section of our Audit Log API. Thanks for watching, and be sure to subscribe for more practical .NET and software development tutorials.